Guys, here's a little video on polynomial operations and polynomial expressions. So on the first set of questions here, right, the parentheses are not touching, right? That makes a big difference because the parentheses are not touching is not multiplication. In this case, they give us a sign. It is addition, right? So don't get confused on multiplication. You're trying to distribute these values, multiply. That's not what you do unless the parentheses touch, all right? So in this case, it's just like collecting like terms. Right, over here, 1x squared is a like term with negative x squared, negative 6x squared, right? Because they both have the same variable and exponent. If you add those two values together, you get negative 5x squared. When you add or subtract, exponents don't change. And now here we have positive 5x plus 7x, which gives you 12x. And then the last one here, negative 9, positive 2 together gives you negative 7. And that's your answer. That expression is the result of adding those two polynomials. All right, same thing on the next one, but it gets a little bit trickier if you have a subtraction in between here. Like on this question below. So if we have subtraction, right, you might make a mistake and forget minus negative 6x squared or something like that. So to avoid that, you can just distribute a negative 1 to these three numbers, and all those values change to the opposite sign of what it was, because you're just multiplying by negative 1. So all of these change signs, and now you can just combine like terms like you did on these questions. Negative 1x squared plus 6x squared is 5x squared. 15x minus 7x is positive 8x. And we have negative 6 here. Minus 2 gives you negative 8. And that's your answer. Alright, let's move it along here. On this page, it's just division, right? So you just got to remember your division rule for exponents, right? If you have x to the 10th on top, x to the 5th, you subtract. It gives you x to the 5th. So over here, if your exponents don't change, then there's no variable on the denominator down here, right? But if your exponents do change, then your denominator has a variable down there. With an exponent, unless it's a 1, then you don't write it. So let's do a couple of these so you understand what I mean here. So to know what you divide 5 by to get a 1, right, you can just multiply. 5 times 1 gives you 5. So 5 divided by 5 must be 1. Now make sure it works for all the numbers to avoid a mistake here. Negative 20x divided by 5, negative 4x. Perfect. 10 divided by 5, positive 2. So it matches. Because the exponents didn't change, it's just 5. But on this one, 12 divided by 4 gives you 3. All these numbers divided by 4 give you those values there. But the exponent changed. That means there was an x down here. Because an x has a 1 exponent, and you would subtract 3 minus 1 to get this 2. So here, the denominator has to be 4x to make it true. Alright, same thing on this one. It's a 9, because 9 divided by 9 is 1. You know the rest work. But this time it changed by 2. So that means it was 9x squared down here. So 9x squared has to be the denominator. Alright. Now on this page, it's just a subtraction question up top. But they're asking specifically for the coefficient of the x to the third term. Right? So you can do all of it if you want, but really you only have to do the operation to these two values. So you have a minus in between. 7 minus 2.1 gives you 4.9. But they only want the coefficient. Don't put the x to the third there. We know it's 4.9 x to the third, but they only want the coefficient. Coefficient is a number that's touching the variable. It's being multiplied to the variable. Alright, so this is just a little word problem, right? Any rectangular figure with a rectangle inside, in this case, it's a Japanese rug. Alright, just visualize it here. There's a decorative portion inside here. The borders are all E, according to what they say in the words here, up top in the word problem. And then it says that the center area has a length that is 3 times the width. So that's the only information we're given, right? So now let's answer these questions. The length of the rug, right, would be from one side all the way to the other, right, which includes 2 borders. So we know the length has to start with, has to have a 2e in it, right? So let's just write it over here. 2e we know belongs to that first question. And now, the inside part here, right, is that, well, the length itself we don't have, right? These are all w's, but we do know that the length is 3 times the width. So we can do 3 times the width plus your 2 borders. Unless you're not including the borders, and these would be minuses on these expressions. So we already have the answers to the first one. 3 times the length, because it says length, right? Plus the 2 borders. 2 borders are 2e. So 3w plus 2e would be the expression for the length of the rug. Now the width of the rug, right? This is L here. Let's call this the width. The width of the rug is the same thing. There's 2 borders on both sides. So in this one, it'll be w plus the 2 borders. Again, if this was subtracting the borders and just counting the the outside minus the borders, then you would have to have a minus on the expressions. But we're using the expressions they give us. In this case, I give you. So here, the area of the center, right? How do you find the area of the center? You multiply the length times the width, right? But the length times the width, we don't have the length. But we do know the length is 3 times the width. So this would be 3w times w. So it has to be this one right here. Simple enough? Alright, let's move it along. Now we get to parentheses touching like this. So when the parentheses touch, you have to distribute, right? It's the same as when you distribute any number into a parentheses, right? Multiply by both numbers in the parentheses, or 3 numbers in this case, right? On the second question. But in this case, you have 2 terms on the front, so you just do it to both. So we do 2x times 3x, gives you 6x to the second power. Let's do it down here, so we can have space. Two x times 3x, 6x to the second power, because you add these 1 exponents. 2x times negative 7, negative 14x. We should have 2 results because we distributed that number to 2 values on the other side. Now we distribute the 3 the same way. 3 times 3x, positive 9x. 3 times negative 7, negative 21. Now the like terms are always going to be in the middle when you're multiplying 2 binomials like this. So always combine these in the middle. Negative 14x plus 9x is negative 5x. The first and last term always just come down. And that's your answer for number 1 here. Alright, let's try this next one, right? This next one's the same thing, but you're going to get more results because you're distributing to 3 values. That's all. But the process is the same. Distribute, you get 12x to the 4th power. Distribute here, you get minus 24x to the 3rd. Distribute to the final number, and it's positive 36x squared because there's no x on the 9. Now, those are 3 results. Now you distribute the other number to those same 3 values. And we get these values right here. Now combine like terms. The front term, 12x to the 4th, has no like term to combine with it. The next term also doesn't have a like term to combine. But you do have 2x squared terms. Put those together and you get 45. And then the constant at the end, well, minus 6x comes down, nothing with it. and positive 9. Oh, let's not minus 6x here. Let's bring down the minus 18x that we have and the plus 27. So the numbers in the front usually don't have like terms. The numbers in the back usually don't have like terms. And now this whole string of numbers is your answer because none of these are like terms. So just remember, a binomial multiplied to a trinomial, you're going to get 6 results, and you just combine like terms to get your answer. Over here, you're going to get 2 results for each, which is 4, and the like terms in the middle must be combined, always. Alright, this is just a factoring lesson. If you watched the quadratic video, we did some of this, right? But it's simple. You want to first find the greatest common factor between the coefficients, and then you need the lowest amount of variable, right? Variable exponent. So think about it. What do they have in common? It can only be the lowest amount of x's that they both have, because common means they both have it. So if one has 100 and the other one has 2, you can only take out 2. So that's the concept for the variables. Let's do the coefficients first. 12 and 18. All right, they're both divisible by 2, but that's not the greatest common factor. You have to get the biggest factor that goes into both, which is 6. So here, 6 times 2 is what you break down 12 to. X is here 4 times. Y is here 9 times. Now I'm only writing it down so you get the concept on the first one. If we do the second one, I'm not going to write them down. I'm just going to take the lowest amount of variable. But for the sake of explanation, let's break it all down here. So 6 times 3 for 18. You have 6 x's being multiplied. That's why it's x to the 6th power. And 2 y's. So now we can circle what they have in common. They both have a 6. And they both have the lowest amount of variable. 4x is here. So you can only circle 4x is there. So we know if we take out 4x's. And 2 y's only. So y to the 2nd can come out. Now you open the parentheses. Whatever you did not take out of here is still in the parentheses when you're factoring. So whatever you don't see circled that you took out is still in here. So on the first term, 2, how many y's do we have left in there? 1, 2, 3, 4, 5, 6, 7. So 7 y's. Y to the 7th power. No x's left, so you don't put an x there. Now over here you have a positive 3 left, so plus 3. And the only variables left are 2 x's. So x to the 2nd power. That is factored. Right? Now, same concept if they ask you what is the greatest common factor, right? We do the same process. Between 16 and 24, the greatest common factor is 8. So 8 times 2 for 16, 8 times negative 3 for negative 24. And now what's the lowest amount of variable? We have x3, x to the 3rd, x to the 5th. X to the 3rd is the lowest amount. So we can take out 8, x to the 3rd. And now for the y's, only one in common because you have an 8 here and a 1 here. Right? If it says factor, you open your parentheses and keep going. If it says what is the greatest common factor, you're done. That's your answer. All right, now let's say they did say factor to make sure you remember this process. Right? If we took out 3 of these, right? How many are left if there was 5 originally? 2 of them. So here we have 2 and x to the 2nd power because we had 2 left. And we had 7 y's left on the next term. I mean on this term. So y to the 7th. And on this side, all we have left is minus 3. And no variables because 3 and 1 both got taken out here. So if it says factor, this is your full answer. If it says what is the greatest common factor, it's just this. What you factored out. Alright, hopefully that helps. See you tomorrow.